Hello Physics, wave nature of light, double slit experiment. And the problem is the monochromatic light falls on two very narrow slits, 0.048 millimeter apart. Successive fringes on the screen, 5 meter away, are 6.5 centimeter apart near the center of the pattern. Determine the wavelength of the and frequency of the light. So the double slit experiment. So this is a source of light. So these are the two slits. So S1 and S2, and this is a screen which is 5 meter up away, 5 meters, and this distance is 0.048 millimeter apart. So this is first one, fringe. So this is a fringe 1, and there is another fringe. This is fringe 1. This is fringe 2. So this is the center. Okay. So constructive interference. So the path difference. So path difference is, this is S1, and this is slit S2. So this one. So this is path difference. This is A distance. This is A distance. This is the extra distance. So the path difference D is multiple of wavelength of lambda. D sine of theta, this is angle theta, is equal to n lambda, where n is equal to 0, 1, 2, 3, so on. So this is equation number 1. And screen, this is screen. So screen, and this is the height is y1, and this height is y2. So screen, so this fringe is y is equal to, this is length L into tangent of theta. So from here, so this is theta and this is also theta. So this is equation 2. Now we will use a small angle approximation. That sine of theta is equal to theta when theta is small. And tangent of theta is equal to sine of theta. This is equation number 3. So if equation number 3 is true, then we can take sine theta from this one. So sine of theta from equation 1 is equal to n lambda over t. This will go in equation 2. Equation 2. So equation 3 and this one. So y is equal to L, and this is a small angle approximation is equal to sine of theta. is equal to L sine theta is equal to n lambda over d. So this is equal to n L lambda over d. This is equation 4. If so adjacent fringe. So the order is 1, delta m is equal to 1. Say if it is 1, other one is 0. So this one, so delta y, the height of the fringe, is equal to n. So this 1, n is equal to 1. So this is equal to L lambda over d. So into delta m. So delta m, delta n. So delta n is equal to 1. So is equal to L lambda over d. This is equation 5. So from here, so lambda is equal to L. So lambda is equal to delta y d over L. So equation 6. So delta m is equal to 1. So already we have used 1. So from here, so if you substitute the value, then we can find the value of the wavelength. Lambda is equal to delta y, the fringe spacing, which is given 65, 6.5 into 10 to the power minus 2 meter. So lambda is equal to delta y d over L. D is slit spacing, which is equal to 0.048 millimeter 10 to the power minus 3 meters over L. Length is 5 meter. So the wavelength is equal to 6.2 into 10 to the power minus 7 meter. So this is wavelength. This is first answer. And then frequencies. Frequency we have to determine. Frequency f is equal to c over lambda. This is equal to c is 3.0 into 10 power 8 meter per second. Lambda is 6.2 into 10 power minus 7 meter. So the frequency is 4.8 into 10 to the power 14 hertz. So this is frequency and the wavelength, and we use these formulas. Here is the delta m. You can substitute this one, and here we can say, so over delta m, generalize this one, delta m, and is equal to 1. So this is the answer of this question.